All right.
Really good.
Notebooks out. Back row. Notebooks out. Continue the stories later. Thank you.
You were. I just gotta go hard.
Go hard.
What am I gonna do today? Don't give me.
Waiting. So, write these down. The top one should be familiar. It's a radical sign. This is what's called a positive square root. A full square root has a plus minus in front of it. It has two answers. But the reason they call this a square root, everybody focusing up here?
Yes.
Is because there's actually an invisible 2 there. They almost never write it, but that's sort of there. It's a little like having a 1 in front of an X is invisible. It's there, but they almost never write it. Because everybody knows what it is. Same thing here. This symbol was universally recognized as a square root.
Oh, because you divided it by its own number.
Because, yeah,
Oh, yeah,
if you have, I'm just gonna make up something.
Please divide it.
If you have 4 squared equals 16, then the positive square root of 16 is 4. You can go forward and backward.
Oh,
It undoes a square. The square root undoes or cancels a square. Quick question.
so like for the 3, you can multiply the number in the middle by 3.
Very close.
Divide it, whatever.
No, can I explain?
No.
Hold on, hold on,
Is
hold
my
on.
Being
This is a square root, positive square root, which we call a radical, because it cancels a square. That's why we call it a square root. Now, what if you had 2 cubed is 8, which is true, by the way. 2 times 2 times 2. Somebody familiar with 2 times 2 times 2, the power?
Yeah.
Yes.
Can anybody take a guess what that is? What?
2.
It's 2.
Oh my gosh,
Oh
it's
my
actually.
goodness,
Oh
right?
wait a second. So do you find the square root of it and then divide it by 3?
Except they change one word. What's the, does everybody remember the nickname for
square
raising
cube.
something to a third
Oh.
power? It's not a square, it's a cube.
Whoa!
So this
Love that.
is called a cube root
I got it right.
because it goes backwards from a cube.
Oh, 'cause
So it's finding
square
what-
root, and then the cube.
Oh
Right.
my gosh.
Cube root.
Good job, Gigi.
Not sorry.
Okay.
Oh, that makes no sense on context.
Set. I agree, I think, because I have absolutely no idea what you're talking about. So, cube root is looking for a number times itself 3 times. That'll give you the number. Like, for example, does anybody happen to take a guess at the cube root of 27? Go.
9.
Close.
3.
3.
Oh.
Boom. I said 3.
Prove it. Mary.
3 times 3 is 9. 9 times 3 is 27.
Right. Because 3 times 3 times 3 is 27. You have to have 3 of them for a cube root. 2 of them for a square root. 3 of them for a cube.
Oh wait, so can you just do
Hand up first. Go. Right.
So what if it were like 26?
26. So the cube root of 26, it's a disaster decimal. It's kind of like the square root of like 13. It just, yeah. Does it exist? Yeah. Do I want to hit it? No. It's, you can estimate it. It's a little less than 4. Yeah. Mary. And then I'll get you.
dividing by cube roots? Is it the same thing?
Oh, trying to get the radical out of the basement? Interesting question. That's actually a pre-calc question, believe it or not. The short answer is usually yes. We're not that would make an interesting extra credit question.
No thanks.
Let me play with that. The question is, if you have like this, if you have 3 over the cube root of 2, do you have to get the radical out of the basement? Technically, it's not a radical, it's a cube root. But most mathematicians would say yes, you've got to get that out. It's harder than a square root. Because if you multiply it by itself, it's not enough. You need 3 of them. For a cube root, you need to multiply. Remember, you're trying to find a number that goes 3 times, not 2. So you can do this. By the way, if everybody else is not understanding what this is, just pretend this is a bad dream and you're going to wake up in about 20 seconds.
Okay.
This is 2, and this is 3 times cube root of 2 times cube root of 2. That would get the radical out of the basement. If you want to see a real disaster version, that's really 3 times the cube root of 2 squared. Yeah. Because a radical times a radical is a radical, no matter whether it's a square root, cube root, quarter root, etc. Just so you know, they actually start running out of fancy names. This is called a 4th root, 5th root, and it goes 6th root, 7th root, 8th root, blah, 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 blah. And then you call this an nth root. I'm not making this up. It's just whatever number, if this is like 58, it's the 58th root. Does that exist? Yeah. By the way, if you think that it's impossible to do something that big and beefy, you'll be able to do it in about 10 seconds. Watch this. Can anybody think they can get the 20th root of something? Something times itself 20 times.
1.
Oh, you read my mind, Jordan. Yeah. The 20th root of 1 is 1. All right, you can probably do one more.
0.
Yeah, okay. Good, 0. All right, smarty chances.
That's a good thing for you. Wait.
Go ahead.
Wait.
I dare you.
Use a calculator.
You can try.
I bet it's.
Never mind, don't use a calculator. That's a
You're
bad idea.
serious.
Oh! You got it.
The reason
that
is-
was a guess. You did not use
Oh,
any
it's
calculations of it.
This thing is 2 to the 20th power.
So.
Yeah. I'll show you one that almost anybody can get. Watch this.
7.
Don't work too hard.
7.
How do you get that so fast?
Because you
Because
said
Mary
7
did
squared it by 3 and then like.
That's
you
squared
that,
by
square root cube it,
cubed.
cube it, and then b cube it, and get rid of and then
The cube and the cube root cancel. And you're left with 7. Exactly.
I have a question.
Real fast.
Okay, so back to what we were doing before that, the 3 and then the 27.
Yeah.
So can you just divide it 27 by 3?
No.
And then
Unfortunately,
divide it
no.
again?
Oh, well, kind of. You have to guess at what number you're trying to do.
Wait. So can you whatever? Wait. I know what you can do. So you can do
Okay.
the
Does everybody
3.
have these, by the way? I need some space.
Yeah. You
Okay,
can do
go
the
for it.
3 and then you can square it. So then it's multiply it by itself, which is 9, and then you do 9 divided by 27, which is 3. 27 divided by
I
9.
think I know what you mean. Well, let me just give you a sample.
So then 6.
Almost everybody says 8.
It is
It's
8.
not.
No, it's 4.
The square root of 64 is 8. What?
4.
That's 4.
I knew it was
Prove it.
16.53.
Prove that 4 works. Go.
You divide it by 4,
Okay.
and then you divide it by 4 again.
No, 4 times 4 is 16, 16 times 4 is 16.
Another way to show that, 4 times 4 times 4 is 64. Or you could say 4 cubed is 64. So yeah, it does work. You getting the hang of this? So the first 5-6 minutes of this is just getting you used to the words. square root, cube root, fourth root, fifth root, etc. Now, if you'd be so kind, do you know, Dylan? I was gonna use-
Wait, me?
No, no, no.
Oh, good.
I'm just getting people quiet.
The first time is that time.
I am moving on to the next point. So keep the talking to 0 for a moment. Now, you know how at the beginning of the year, I suggested it would be good to memorize the perfect squares, probably up to 144. 169 is good. It's like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So 1, 4, 9, 16,
18, 20, 25,
25. Let me just write these down.
36, 64.
Hold on a second. 149. People are yelling over each other. That's not going to be helpful.
I didn't say anything.
John, help me out. Give me the first 2 rows. 149, 16. We got that.
16, yes.
Keep going.
25.
Yes. Now next row.
47.
This one.
No, 36.
36.
49.
Yes. So 6 times 6, 7 times 7. What's 8 times 8?
64.
64. What the heck am I doing?
Yes. Be quiet.
Keep going.
81.
81 and
121.
I missed one.
100.
100. All right.
Incredibly dumb, it's
Who
hilarious.
think they can do the entire next row of
I
5?
can.
Brendan, go.
121.
That's 11 times 11.
136.
A little higher.
I know.
12 times 12.
144.
144.
169.
169. This is where things get a little tricky. 14.
196.
Without a calculator.
And 196.
196.
And then don't say anything. I got this. 15. 225.
225.
Easy double.
Good. I had recommended that you memorize at least up to 144. 169 is better. And the more you can, I can't hear. The more you can memorize, the better off it is. You know how we've been reducing radicals and things? Spotting these in radicals, the bigger the better. So if you can spot a 225 floating around in your radical, that's going to save you a lot of time. Now, these are what we call perfect what? Perfect squares.
Oh, let me write that down.
Yep.
Oh. Oh.
I'm not going to do as many because they get huge.
Squares down.
Perfect cubes.
Okay.
No.
Now, in order to do these, you don't have to do them lickety-split, but do them correctly. For example, Eric, can you give me the first 5 of them? What's 1 times 1 times 1?
1.
Yes. What's the next one?
2 times 2 times 2 is 8.
8.
27.
27.
Wow.
Now, 4 times 4 times 4.
60.
16 times 4.
Good question.
32.
By the way, there's a hand up there.
Oh, 64.
64. Does anybody know 5 times 5 times 5? Go. I didn't know. Go. 125.
Wow, look who's
Now, I'm going to do one more row. 6 times 6 times 6. I hope you're not
36
superstitious.
times 6. 36 times
The
3. I
Antichrist
can't do
is
that. I did calculate. What did you say?
I said the Antichrist sneaked into our math problem. 6 times 6 times 6. That's a joke.
Oh my
Sorry.
goodness.
Don't get superstitious. So, go ahead. 6 times 6 times 6. Or whatever.
I'm terrible at math.
Oh, okay, go ahead. 216.
I said that. 7 times 7 times
7 times 7 times 7.
249.
Mm.
252. 280.
285. 3
I'll give you a hint.
296.
You know how you do
Oh!
7 times 7 times 7?
Is it 296?
Do this 49 times 7?
343.
Yeah.
Ah. What digit does this have to end in?
A 3.
3. Because 9 times 7 is 63. So this is 343. 8 times 8 times 8. Anybody know?
524.
You're in the ballpark. A little too high.
What is 60?
516.
Closer.
519. 520.
532.
Too high.
29.
5, what's the?
You're all too high.
502. 408.
That was a little too low.
508.
That's it.
Was I close for this?
Oh, dang it.
512.
Hey, let's go.
That was 8 times 8 times 8. Anybody know 9 times 9 times 9?
No. How would I know?
800.
It's the upside.
729.
729.
How are you guys even getting
That's
this?
something.
The sneaky one is, what's 9 times 9?
81.
81. Now think of that in your mind. 81 times another 9. What I do is 80 times 9 and 1 times 9.
Oh, 90.
So 720
Oh, times.
and a 9. And you should be able to get the last one.
100,000.
A little too many zeros. 1,000.
I meant that.
10 times 10 times 10. Those are the perfect cubes. They keep going, of course. 11 times 11 times 11. I don't even know what that is. Blah, 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 blah. The perfect fourths are also a thing.
It's perfect.
I'm not going to list those.
Yes, please.
Yeah.
It'd be like
So in other words, 1
1,
times 1 times 1
16.
times 1, 2 times 1, 16, 81.
81? How
Is
did
3, 3, 3, 3. Yeah, which is basically 9 times 9.
Oh, it's 81.
Right. So it'd be like 1, 16, 81.
Stop messing around.
Heaven only knows. Hang on a second.
Infinity. Yay.
256. 625. I'll give you a hint.
793.
If you want to get, they're sometimes called the quads too, the perfect quads. Here, multiply another 2. You already have 3 2s, just get another one. Gentlemen, talking way too much. Rob, Eric, be aware of your surroundings and your volume. This, there are 3 3s already, multiply another one. 27 times 3, which can be annoying, but it's 81.
How do we get to 1,000?
This, multiply another 4. So 60 times 4 and 4 times 4. 240 and then 16, 256. And so on and so on. So there are tricks you can use to make it a little fast. Everybody clear on those? So what if somebody gave you this?
No solution.
4th root of 729. 9.
Oh, you count them.
Because that's the 9th one of these perfect.
6, 7, 8, 9.
Or actually, sorry, I should have done that. Wait a minute.
It's third grade.
I did, yeah, sorry, that was puberty. My fault. I got the wrong one. I forgot to even write the quads. Gentlemen. You're still producing a lot of volume. I'd rather you not. Everybody clear on that so far? Kind of make sense? Now, when would this stuff ever come in useful? Let me show you. This is what I call the anti-calculator exercise. I'm not saying calculators are evil, sometimes I do, but I want you to know how to do math without it. I don't want you to, I mean, people when they get their hands on a calculator when they were really young, their brain changes. It's sort of like, there's something deep in the deep dungeons of your brain that says, I will never really have to do anything in my head because I will always have a calculator. That's not true, for one thing. You never know when a calculator will break, or your little brother will eat it, or what have you.
Wait, I have a better answer. Just don't get a job that includes math.
Good luck with
That's
that.
actually a pretty good answer. Everything.
You'd be surprised.
Well, then
But
you use your computer.
You use your computer. Yeah, literally everything.
Google it. Google the answer.
graph y equals x squared for me.
No.
This is apparently had nothing to do with this. It actually is. But I'll have to show you how. Can somebody tell me how to graph this thing?
Wait, do you start?
Stop.
Oh.
Go ahead.
Oh. Wait. What? So, what do you want?
How do you graph? I want to graph this.
Oh, so you make sure that x is touch the X point first? I mean,
Get a little more specific.
Why?
Okay, first of all, raise your hand.
Oh, I did, I thought.
You didn't, but, okay, go ahead. Gianna, go ahead.
So the X line, you have 2 points on it.
Normally, yes. Normally, absolutely. When you have a squared, it normally hits twice. There are a few exceptions.
Oh, wonderful.
Let me show you. If you don't, by the way, is this thing gonna be a line?
Yes, no,
Which one?
no.
Yes or
It's
no?
gonna be no.
Why not?
Because it's a curve.
Parabola.
It's a parabola. Squared changes the shape. If it were y equals x, that's a line. Yeah, question.
Technically, it'd still be a line. Or is it
No.
just be a squiggly line?
In geometry, a line is something that doesn't bend.
And it also
It goes
never ends.
straight.
That's not what we learned.
This
Yes, we didn't learn geometry.
is a line.
That's just one segment.
This
No, he's got the arrows on his end. It's a line.
is not a line. It's what we call a curve. By the way, well, I don't want to get too technical. It's actually a bending curve.
Why don't we do a line segment?
But isn't a curve a line that's bent?
I wasn't going to get into this. I'll give you 30 seconds just because the question actually kind of fascinates me. A curve is basically any unbroken string of points. It's something you can draw without lifting your pen. Think of that.
Oh, so it's a line. You can
A
draw
line is technically a curve. It's called, it's in geometry, a line is a straight curve that extends both ways forever. So in street language, we use line, like curve and straight, as being two different things. It's either straight or it's curving. In geometry, a curve is anything you can draw without lifting your pen. An angle is a curve. A line segment is a curve. It's just a curve that doesn't go very far.
Wait, it is, but it's straight.
A curve, I was just explaining that. In geometry, a curve is anything you can draw without lifting your pen.
Wait, but you can draw like everything without lifting your pen.
Not necessarily. Like this. I had to lift my pen once to draw that whole shape. If there's a break in it, that's not a curve. That's actually two separate curves.
Why does there need to be a break in?
Because I made a break.
Yeah, but
In other words, there are lots of things that have breaks in them. And if something you can be drawn without lifting your pen, it's a curve. Is there something in geometry? Could there be such a thing as a straight curve in geometry? Yes. Here's a straight curve. This is what we call a bent curve. Bending and curving are not the same thing in geometry. Bending means you're actually going away from straight. Curve just means you can draw without lifting your pen. Moving on, sorry, I know it's tantalizing, but this is a curve that's not a line. Real fast, you gotta be 30 seconds or less.
Okay, so let's say you draw one line and then you have a space and then you draw another line. What if you connect those two lines? Is that a curve?
If you connect it, then it becomes one curve. If it's not connected, then it's two little curves.
I'm done.
You didn't even hear the answer. Jana, stop arguing. Brendan, you didn't hear my answer, correct?
Well, you said yes.
Yeah, let's try it again. You had said if there were two little curves and you connected them, would that be a curve? Yes, it would be one big curve.
Yeah.
If you didn't connect them, it would be two little curves. Make sense? Real fast.
But why is that? Because a curve is describing the shape of a line. So wouldn't it just all of it be lines?
In street language, yes. In geometry, a curve is any unbroken string of points, whether it goes up, down, left, right, straight, curvy,
Why
spiral.
does it do that?
Ask the people who invented geometry. For right now, put a dot at 0, 0. We're moving on. Put a dot at 0, 0. Put a dot at 0, 0, which means you have to draw the graph first. People who didn't draw the graph, get on the stick. Draw the graph, no pun intended. Get on the line. Okay, so go ahead. Question.
Is there a math problem that would make us like a whale sort of thing?
Short answer, yes, there is. It's extremely involved, and it would not be an equation you'd recognize. But yes, it is possible to make a spiral.
Is that like calculus, pre-calculus?
Yes and no. It's actually kind of a different branch of math altogether.
Um,
I can you can actually do it on a graphing calculator too.
You had a
But so I'll show you later. For now, put a dot at 1, 1 and 1, -1. How do I know this? Because the way you graph any shape you don't know is use a table. You've done this before. You pick a bunch of x's and then crank out the y's. Can somebody tell me what y, if I use this formula, what would be here? Go ahead, Miranda. 4. You're good. Do the next one for me, wait. 1. Keep going. Yeah. 0. Good.
Is the x 1?
Yeah, the x is 1.
Okay, 1
1.
and 4.
See how we get this? -2 times -2, squaring it. So we have -2, +4. Then -1, 1. Then 0, 0. Then 1, 1. Then 2, 4. You can keep going, 3, 9, blah, blah. It's actually going to make a sort of a U shape. It's rounded on the bottom. And this is called a parabola. It's called a parabola. Now, what use is it? Try and graph it relatively accurately. On the test, I'll probably just print one for you to make sure that it's really, like, exact. I want you to estimate (1.5) squared. And by the way, estimate, have you seen this sort of squiggly equal sign? Have you know what that means?
It means approximate.
Approximate. It means roughly, close to. Here's what you do. This is x. Estimate what the answer will be. Now the answer is actually 1.5 times 1.5. That's actually not too hard to do by yourself.
Wait.
You could do it on a piece of paper. And then to make sure you carry the decimals over, blah, blah, blah. But I want to show you a really, really quick way to do it if you have a graph. Pretend x is 1.5. This is 1 and this is 2. Here it is. Okay? Do me a favor. Shall we focus and not be distracted? Can we make sure that doesn't happen again? Watch this. Draw a line straight up until it hits the ground and then stop. Just straight up. Don't try and follow the graph. Just go straight up until it hits. Can somebody tell me how high up that is? Roughly.
Yeah, that's actually kind of cool.
How high up is it? Just give me a real rough guess.
2.5.
Yeah, a little it's a little less than 2.5, so I don't know, what decimal would you want to call it?
2.3.
2.3, 2.2, 2.3.
Mine's 2.5.
I was just,
That's not a bad estimate. The real answer is 2.25. So 2.3 is, and 2.5 is actually a pretty good guess. It's a real quick guess. This can help you estimate what I call bad numbers. Let's show you just how icky it can go. Gentlemen, if you're talking and laughing, getting in the way. Click. Try this. Estimate -1.2 squared. Now you have to kind of guess. This is -1 and this is -2. -1.2 is just a little bit beyond. What do you think?
Wait a second.
I just want to, like here, is like -1.2. I just want to know how high up is that when you hit. Give me a real rough guess. Aaron. How high up is that, kind of, sort of? This is like 1 and this is 2.
1.5.
It's 1.5. That's actually very, very close to the real answer. The real answer is 1.44. 1.5 is a very good estimate. And you did it in like 2 seconds. So when you have not much time but you have a graph of this, which you can always make it ahead of time, you can find some fairly quick and fairly good estimates just by following the graph. Let me try a different graph. Same sort of thing. I'm going to erase the perfect cubes here. I want to see who can graph this. Graph the following. Y equals radical x. Now, not square root, radical. The rule of this is whenever you run into a new function you've never seen before, make a chart. What numbers should you plug into your chart? What do we usually do? Yeah.
-2, -1, 0,
-2, -1, 0, 1, 2. I'm going to do that. I'm actually going to carry it a little further. 3, 4, 5, 6, 7, 8, 9. I normally don't go that far. Go ahead and go that far, just once. Because there are a few surprises in this chart. Curious if anybody sees any of them. How am I going to get the y's? Andy, what do you think? Here's the formula.
You can't do negative.
What?
You can't do negative.
You cannot do a negative. The square root of -2 doesn't exist. There's no answer. How about the next one? None. What's the square root of 0? That does exist, it's 0. What's the square root of 1? 1. Square root of 2?
2.
It's a decimal. I don't know what it is. What's the first number that has a nice answer? 4. Skip down to 4.
2.
The answer's 2. How about 5? Good or bad? Bad? 6? Keep going. Bad?
Good.
Good. It's 3.
7.
See that?
1, 2, 3.
In other words, I skipped all of the ones that are icky. That's legit, as long as you label it. Let's graph this thing. The very first dot that actually worked is what, Mia Jacker? 0. 0 comma what? 0 comma 0. What's the next dot? Go ahead, keep going. What's the next dot that actually worked? Actually, we missed one. 1 comma 1. And then keep going. 4 comma 2. Okay. Put it out there. And then one more. 5, 6, 7, 8, 9 comma 3. If you draw it, it should look like this. Does anybody recognize it?
Bending. It's a parabola.
Sort of.
It's half of
Half a parabola. And it's a weird parabola because it's going which way? To the right. Normally parabolas go up. This one's going to the right. How do we get parabolas to go to the right? That's at least an Algebra 2 question and possibly pre-calc question. But for right now, does everybody see just visually it's half of a parabola? It's the upper half of a sideways parabola. So here's my question. Estimate. Radical 6. How? How do you use the graph to estimate radical 6? Yeah.
Well, this is wrong. Do you do an XY table thing? No, that's wrong. Yeah. Okay.
Well, we did.
Thank you.
No, you're on the right track. We did use a 6. We gave up because it was a decimal. Look at the graph. Is this x or is this y, the 6 that we're using?
It's X.
It's x. Whatever you plug in is x. Whatever you get out is y. Can you find x equals 6 on the graph, Jack? Like, where do you look for x equals 6? How do you, where? What direction do you go? To the right. It's right here. Now, what do you do to the graph to find your answer? Yeah.
You go up the half parabola.
Go straight up and see where you hit. Give me a rough estimate. Roughly what?
2.5.
Roughly 2.5. Let's see how close you were. Radical 6. Oh, I didn't even turn it on.
2.49.
All right, fine. Fancy fingers, hang on. 2.449. This is an excellent estimate. This is very close to the real answer. And if all you need is an estimate, you got it in way faster than, and assuming you don't have a calculator. Finding squares is hard enough. Finding square roots without a calculator is an absolute kind of a nightmare. So they do have a technique for it. I studied it once and then I deliberately forgot it because it was just so annoying. So like, does anybody actually do this? It took way longer than even guessing and checking. This is much, much faster. Questions so far? All right, take out your books, please. Turn, if you will, to page 682. 682. Grab my spot there. Now, problem 1 and 2 are review. Problem 3, you can skip. I don't think I assigned number 3 anyway. Yeah, I skipped over. For 14C, I skipped over about number 3. For number 4, that should not be too difficult, it's just a little tedious. List the first 5 perfect squares, perfect cubes, perfect quads, perfect quints. Second, third, fourth, and fifth powers. That should be relatively easy. Number 5, use your table to tell whether the following numbers are rational or irrational. Can anybody refresh my memory? How do you tell if a square root is irrational or rational? Like, can somebody give me a square root that is rational? That's nice and rational. Yeah.
4.
Square root of 4. Give me another one. Yeah, got it. 9. 25. What square roots are nice? Like, how do you tell ahead of time whether it's going to be rational? You were giving them to, yeah.
If it's positive, like, no.
What kind of numbers do you plug in? Yeah. Okay, what, I'm sorry. Okay. What kind of numbers what kind of square roots are nice, are rational? You take the square root of a what? A special kind of number. Perfect square. If you take the square root of a perfect square, it's rational. Try that rule on cube root. What kind of number can you cube root and be rational? It's very similar to the last answer. Perfect cube. And that'll be on your table. A fourth root is rational if it's a perfect, they call it a perfect quad, but it's a perfect fourth. And a fifth root is rational if you do it to a perfect fifth. That's actually a music term too, but whatever. Perfect fifth is like, you know, C, D, E, F, G.
Oh, yeah, I get it.
A fifth, yeah. Number 5, that's how you use it. Use your chart on number 4 and see if there are perfect squares or quads or whatever on top and bottom. Number 6, they're doing estimates. Try it. Number 7, they're kind of doing what we did on the board with the parabola.
How do you do that? I'm just.
Kind of like how we did here. Use their picture, and then they're going to ask you to do estimates. So for example, they might say, use your graph to estimate the square root of 10. So if you want to do a square root on this thing, this thing can go backwards too. Look up here real fast. Let's say I want to estimate the square root of 9, or square root of 4. How do we get the square root of 4 if I use a parabola? Go backward. Start with a height of 4 and see how far over you are. How far over are you? Two. Or what? -2. You can go backwards on the parabola. Normally you say, try x and then estimate the squares. But if you want to do square roots, go backwards. Plug in the y. Let's just say, hey, at a height of 1, how far over do you have to be? What would you tell me? Like pretend, hey, I'm at a height of 1. How far over do I have to be in the x to do that? There are actually two answers to that. Anybody see it? Yeah. -1 and 1. This is actually a neat way to find square roots. If you say now, here, let me draw a new one because it's getting kind of mangled. Here's a reasonable sketch of y equals x squared. Please don't start chit-chatting. So here's the normal one. I want to estimate radical 3. Just told you. I want to estimate radical 3. Now this is y equals x squared. If I go over to 3, it's not square rooting it, it's squaring it. Watch this. I can go backward. Here's y equals 3. How far over am I? You tell me. Just rough guess. Andy. 1.8. That's a reasonable guess. 1.7, 1.8, somewhere around there. And what? -1.8. You just answered the problem. To use the parabola to estimate square roots, go backwards. Start with a height and see how far over you go. And you'll have two answers each time. Like on problem number 6a, for example. Or actually, no, sorry, 6d. Estimate the square root of 10. That means you have to go up to a height of 10. And how far over are you? So you might have to draw your parabola a little bigger. Or look at their parabola, I suppose. Oh yeah, they did it. They went up to 10. So just go up to a height of 10 and see how far over are you. Actually, let's try that one. Number 7D. They want a height of 10. What value of x causes that? Give me a real rough estimate.
Did you ever get heat up there? or no?
There is heat. I don't know how, but yeah. It's still sort of hissing steam out,
Oh,
but
okay.
very slight. It's not as bad as
Yeah,
before.
see, that's gotta be all taken apart, and shut off the boiler, just, whatever.
No worries. Okay, we're just enjoying the heat for now. Thank you. Okay.
Yeah, we could just not have things.
Square root of 10. Back to math. Go up to a height of 10 and tell me what value of x it is. Isabella, look at the graph on the right-hand side of page 683, that parabola, the U-shape.
Yeah.
Go up to a height of 10. Follow the parabola over so that it's up 10 spaces. You see where 10 is height?
Yeah.
How far over is the x?
3.
Yeah, is it a little more than 3 or a little less than 3?
A little more than 3.
A little more than 3. Give me a real rough, wild guess. 3.9, 3.2. Excuse me. I'm sorry, say again?
Let's see. 3.1.
That's a very good guess. I would put that as an answer. By the way, is there another value of x that would have the same height? Look on the other side.
Negative 3.1.
Right. So for 7D, I put 3.1, negative 3.1. Those are your two answers. Make sense? All right, you got about 7 minutes. Go ahead and start pounding away at that. Don't forget we have to do, let me see. No, just 14C. Go to it. Call me over if you get stuck. People watching at home, God bless your health or whatever is going on, and see you later. Yes, ma'am. Just a second.